Very good morning to all my dear friends. Welcome to our channel. So, in the previous lecture, we spoken about the Iupac nomenclature, how to name the organic compounds. We studied how to name the simple organic compounds. In this lecture, we are going to study how to name the complex organic compounds. How to name the complex organic compounds. For the naming of complex organic compounds, you should have to follow some steps. There are 3 steps. We should have to follow those 3 steps. What is the first step? First step is the selection of the parent chain in a complex compound. Selection of a parent chain. We will see the selection of a parent chain when there will be a functional group and without functional group. In these 2 cases, we will see how to find or how to select the parent chain. When a functional group is present in a complex compound, then how we should have to select the chain, parent chain, and when functional group is not present, at that time how we should have to select the parent chain. And now, second step, what we should have to follow is that numbering of parent chain. So, in which way we should have to number? In which way we should have to number? Right? We will learn that one. And in the last and the third one, we should have to know the order of names. How we should have to write the name. What is the order of that one? And we studied order of name in the first lecture itself of the Iupac nomenclature. How we should have to write the name. We should have to write the primary prefix and then secondary prefix plus root word plus primary suffix plus secondary suffix, and it is the way in which we should have to write the name. That means it is the order of names. Right? So now we are proceeding with the first step, selection of parent chain. We will see first without functional group how to select the parent chain, and then we will study with functional group how to select a parent chain. After that, we will also give the numbering to the parent chain, and we will learn how to give the numbering. In which way we should have to give the number. To what we should have to give the preference. So many things are there. Right? So for the naming of complex compounds, these 3 steps are very important. Okay? Yeah. Now I am proceeding with examples. Why I have taken so many examples? I will give you so many examples today. What is the reason behind it is that from so many examples, if you are learning something, it will be very easy to catch. Right? So that's why I have taken so many examples. I am starting with the first example. What is the first step? Selection of parent chain. Selection of parent chain. You can see here, I am taking a compound, which is a complex compound right now. Yeah, it is a complex compound. You can see here. So in this, how we can say, that means how to select a parent chain. In this compound, how to select a parent chain. You can see here, we should have to see the carbon chain. We should have to see the carbon chain in which carbon atoms numbers will be more. In which carbon numbers will be more. You can see here, I am considering this as my carbon chain. And I am saying like it is the first carbon, second carbon, third carbon, fourth carbon, fifth carbon, sixth carbon, seventh carbon. That means here the number of carbon atoms is 7. Whenever we are taking a group, or we are taking a branch, or we are taking a chain, I am saying 3 words. That means whenever I am taking a chain, whenever I am taking a carbon chain, I should have to see in which chain the number of carbons is more. In which chain number of carbons is more, and that chain will be known as parent chain. That chain will be known as parent chain. For example, it is the first chain which I am choosing, 1, 2, 3, 4, 5, 6, 7. It is a 7 chain. So that means it is a 7 carbons present in a carbon chain. And I am just considering this one, 1, 2, 3, 4, 5, 6. If I am taking this one, Then in this chain, I am getting only 6 carbons. But in this chain, in this long chain, I am getting 7 carbons, and in this chain I am getting 6 carbons. So in which the number of carbons is more. So whatever I chosen in the first one, whatever the chain present here, in a straight one, I taken a chain and it has 7 carbons. That means here it is having more number of carbons. Then this chain will be known as the parent chain. So while selecting the parent chain, we may have so many chains in a complex organic compound, but we should have to select the chain in which more number of carbons are present. So I am seeing here 2 chains. First is this one. Here 7 carbons are present in this chain, and the second one is this chain. In this carbon chain, you can see 6 carbons are there. I can see the third possibility too. What is the third possibility? I can come from here 1, 2, 3, 4, 5, 6. From here to, if I am seeing my third possibility of the carbon chain, it is the 6 carbon. It is the 6 carbon. 1, 2, 3, 4, 5, 6. That means in the third possibility too, I am getting 6 carbons. Right? In the first possibility of seeing the chain, how many number of carbon atoms are present? 7 carbon atoms are present. As in the first chain, 7 carbons are present. As it is the more number of carbons present in the chain, this chain will be considered as the parent chain. So it is the parent chain here. I'm just rubbing this one. Yeah. It is a parent chain. Right? 1, 2, 3, 4, 5, 6, 7. Right? So it is the parent chain, as more number of carbon atoms are present in this chain. So whatever the left out molecule is there, or whatever the left out from the compound is there, whatever it is left out, that means whatever from the parent chain left out, that will be known as substituents. Right? So this one is known as substituents, as it is left out from the parent chain from a compound. As it is left out from the parent chain of a compound, it will be known as substituents. Right? It is how we should have to select the parent chain. We should have to give the preference to the chain which is having more number of carbon atoms as a parent chain. Right? What I am having doubt is that if I am having a carbon chain, yeah. You can see here, what I am doing is that, you can see here, we should have to select the parent chain. How to select the parent chain? We should have to see the possibilities of the chains. I am saying my first possibility is that 1, 2, 3, 4, 5, 6, 7 carbons is my first possibility. My second possibility is that 1, 2, 3, 4, 5, 6. So this possibility is not possible, because whatever the chain I chosen in the first one is longer than the second chain. That means first chain is still the parent chain, but it is not yet confirmed still now. What I am doing is the third possibility, 1, 2, 3, 4, 5, 6, 7. So here too it is coming 7. In the straight too it is coming 7. In the straight, when I taken the carbon chain as a straight chain, I found there are 7 carbon atoms are present. In this chain too I am finding 7 carbon atoms are present. Third possibility, 1, 2, 3, 4, 5, 6, 7. Here too I am getting 7. That means in 3 ways, in 3 chains, I am getting 7 number of carbon atoms. And one more possibility is that 1, 2, 3, 4, 5, 6. It is the fifth possibility which I have seen now, and here only 6 carbon atoms are present, as we have already 3 chains which is having 7 number of carbon atoms. 7 carbon atoms are present already in the 3 chains. Then it will be not a parent chain. So definitely from this chain, it is the first chain in which 7 carbon atoms are present, and then it is the second chain in which 7 number of carbon atoms are present, and it is the third chain in which more number of carbon atoms, that is 7 number of carbon atoms are present. Right? So which chain we should have to select? Because in 3 chains, what I am saying is that the number of carbon atoms are same. Right? In this chain to 7 carbon atoms, in this chain to 7 carbon atoms, in this chain to 7 carbon atoms. Then which chain we should have to take? Then we should have to take the chain, we should have to take the carbon chain in which more number of branches are there. In which more number of branches are there. For example, you can see here, if I am taking this as my parent chain, you can see here there is 2 branches. It is the first branch and it is the second branch, right? If I am considering this as a parent chain, then it will be my first branch and it will be my second branch. If I am considering this as my parent chain, then I am just getting only one branch, right? I am just getting only one branch. You can see here 1, 2, 3, 4, 5, 6, 7. You can see here I am just getting one branch. What I told is that we should have to select the parent chain. If the number of carbon atoms are same, we should have to select the parent chain in a way so that more branches will be there. Here only one branch is there, but when I consider this as a parent chain, I had 2 substituents. That means I had 2 branches, and here only one branch is there. Right? When I am considering my third possibility is this one, 1, 2, 3, 4, 5, 6, 7. You can see here too there is 2 possibilities, 2 branches are there. It is my first branch and it is my second branch. So now I have 2 possibilities of my parent chain and one possibility has been cancelled out because I have just one branch. When I am considering this as my parent chain, I am just having one branch. So it will not be as a parent chain. So I have 2 options. It might be my parent chain or it might be my parent chain. So if you are having same number of branches, even though you chosen the more number of carbon atoms, then we can give the preference to any one, right? So I am giving the preference here. You might choose this or you might choose this, but I will get the same name. I am choosing this one. I am choosing this as my parent chain. I am having 2 branches here. First, it is my first branch which is attached to this carbon of my parent chain, and it is my second branch which is attached to this carbon of my parent chain. It is how we should have to select the parent chain without the functional groups. Here there is no functional groups. You should have to understand. Here there is without functional group. Here there is no functional groups are present. When no functional groups are present, we should have to give the preference like this. Now you may would have understood how to select the parent chain. If the number of carbon atoms in the chain is more, then that will be considered as a parent chain. If we are having so many possibilities for a parent chain, as the number of carbon atoms are same, then we should have to see the parent chain in which more number of branches are there. If more number of branches are there in any one of my possibility, then that possibility will be known as the parent chain, right? So you may have understood. And how to give the numbering. My second one is I am talking about without functional group to how to give the numbering to this one. It is without functional group. How to give the numbering? So we should have to follow the least number rule. My second one is without functional group. In without functional group, my second one is numbering. Numbering I am writing here. Numbering. How to give the numbering? First one is that we should have to follow the least number rule. Least number rule means we should have to give the number in such a way, so that our substituent, whatever the substituent which is present in a compound, should get a lower number, should get the least number. We should have to give the number in that way. So if we are giving the number in that way, in which the substituent is getting a lower number or the least number, then the numbering will be correct. For example, you can see here, I am going to give the numbering to my parent chain. We should have to give the numbering only to the parent chain. You can see here, I am going to give the numbering to this parent chain. So I can give the numbering from this side and also from this side. I am giving from this side 1, 2, 3, 4, 5, 6, 7. 7 carbon atoms are present. I am giving from this side too 1, 2, 3, 4, 5, 6, 7. So you can see here where my substituent is present. My substituent is present at this carbon. So I'm seeing that whenever I'm giving the numbering from right side and from left side, I'm getting the same number. So if I'm getting the same number, then both the ways are correct. But what happening is that if I'm increasing one more carbon here, that means it will be known as the 8th carbon, right? It is the 8th carbon, and I'm giving the number from the back 1, 2, 3, 4, 5, 6, 7, 8. So from the right, whenever I'm giving the numbering, I'm getting the substituent at my 4th carbon position, at my 4th carbon of my parent chain, right? Whenever I'm giving the numbering from the left, I'm seeing that my carbon where the substituent is present is getting the 5th number. That means it is the 5th carbon for the substituent. That means we should have to follow the least number rule whenever we are giving the numbering. So here, what is the least number? 4 is the least number. Then we should have to give the numbering from this side, from 1 to 8 in this side. That means it is the correct one and it is the wrong one. So we should have to follow the least number rule. So, in the second case, what can happen is that you can see here how to give the numbering here. 1, 2, 3, 4, 5, 6, 7 or 1, 2, 3, 4, 5, 6, 7. I can apply here. So you can see 1, 2, 3, 4, 5, 6, 7 or 1, 2, 3, 4, 5, 6, 7. You can see here whenever I am giving the numbering from this side 1, 2, 3, 4 at the 4th carbon, I am getting my first substituent here. There are 2 substituents are present. Whenever I am giving the numbering from this side, I am getting my substituent at the 4th carbon. But whenever I am coming from this side, I am getting my first substituent at the 3rd carbon. You can see here 1, 2, 3. At the 3rd carbon, I am getting my first substituent. So, if 2 substituents are there, or more than 1 substituent are there, without functional group, I am talking about the rules. Without functional group, so whenever there will be more substituents, then we should have to give the number in such a way so that our first substituent should get the least number. So you can see here my first substituent is getting the least number 3 here. But whenever I'm giving here from this side, whenever I'm giving the numbering from this side, you can see this carbon, this substituent which is present at this carbon is getting a number of 4. But here it is getting a number of 3. That means this 3 is the least number when compared to the 4. Right? As it is the least number, that means my substituent is getting least number. That means what I'm saying is that my substituent should have to get the least number if more number of carbon atoms are present. If more number of substituents are also not present, it doesn't matter to me. If more number of substituents present, then also I should have to give the numbering in such a way so that my first substituent should get the least number. If more substituent is not present, only a single substituent is present, then it's very easy. What I'm saying is that we should have to give the least number to that substituent. Alright? Well, it is what known as least number rule. You can, in that we can say one more thing is that lowest sum rule. What? Lowest sum rule. What is lowest sum rule? You can see here. Lowest sum rule is nothing but if you are having doubt, if I am having more than one substituent, then what should I have to do is that you can follow lowest sum rule. It is a second method. You can see here what is the lowest sum rule is nothing but wherever the substituent is present, we should have to take the number and we should have to add up. Right? You can see here what is the number here in the first one 4 plus what is where my second substituent is present here at the 5th carbon, that means 4 plus 5 is nothing but 9, and I am coming from here where is my first substituent at the 3rd carbon and where is my second substituent at the 4th carbon. If you are seeing after adding I am getting the number 7. So which is getting the least number, that way of numbering is the correct way. As I got the least number 7, that means it is the correct way of numbering the parent chain. So you might have understood how to select the parent chain when there will be no functional groups. and how to give the number to the parent chain when there will be no functional groups. So, order of names, how to write the names. You can learn from here how to write the names. So, what is the order of writing the names? First, we should have to write the primary prefix, then secondary prefix, then root word, then primary suffix plus secondary suffix. I am going to write the order of names right now. So, where I can write the order of names, I am writing here for the first compound. For the first compound, you can see here primary prefix plus secondary prefix plus root word plus primary suffix plus secondary suffix. Is there any primary prefix? No, here there is no primary prefix. Why I am saying no primary prefix? Because here there is no cyclic compound. Is there any secondary prefix? Yeah, here secondary prefix is there. Why I am saying secondary prefix is there? Because it is a substituent present here. In a complex compound, substituent will be present, and thus substituent will come under the secondary prefix. So, it is secondary prefix. How many? We should have to see in a secondary prefix how many carbon atoms are present. How many carbon atoms are present in the secondary prefix? You can see here. That means in the substituent 1, 2. Right? In a branch we should have to see if any substituent is there. The substituent will also have some branch. Right? In that branch how many carbon atoms are present? According to that we should have to write the secondary prefix. Here 2 carbon atoms are present. Then what is the secondary prefix here? Secondary prefix is ethyl. Ethyl. Why I wrote ethyl? Eth. 2 carbon atoms are present. Then eth. In secondary prefix we should have to write YL. In secondary prefix we should have to add YL. If here 1 carbon atom is present, then methyl. If 3 carbon atoms are present, then propyl. Propyl. 4 carbon atoms are present, butyl. We should have to write the name of the secondary prefix in this way. We should have to write the substituents name in this way. So while writing the substituents, the main thing what we should have to consider is that we should have to consider the number. The way we have given the number, that number is very important here. So here you can see here, as I taken the 8 carbons, here 8 carbons are present. And here, whenever I am giving the numbering from this side, I am getting the number 4, where the substituent is present. Whenever I am giving the numbering from this side, from in this direction, I am getting the number 5 at the carbon where the substituent is present. Then, whatever I chosen in the first one, whatever the chosen in this direction is the correct numbering, as it is getting the least number, So whatever I chosen is the correct one. So it is the correct one. So what is the number here? We should have to write the number here for that substituent. We should have to write the number for this substituent. Here what is the number? Here 4 is the number here. Right? So we should have to see to which carbon of the parent chain my substituent is present. We should have to write that number before the secondary prefix. Then what is my root word? 8 carbons are present. Root word is oct. Plus what is the primary prefix? As single bonds are present between the adjacent carbons, it is ane. Right? Then what is here there is no secondary suffix because there is no functional group. We already wrote here. It is without the functional groups. Then what is the name of this compound? 4-ethyl octane. 4-ethyl octane. It's very easy to name the complex organic compounds too. And here we are studying without the functional groups. What is the name of this compound? 4-ethyl octane. Now we are going to give the name to this compound. As we study the lowest number rule, we found that this numbering is the correct one and this numbering is the wrong one. Or we can say from the least number rule to what is the least number rule? The substituent should have to get the least number. Even though if more substituents are there, my first substituent should have to get the lowest number. And here it is getting the lowest number of the third carbon. My first substituent is getting the third number. So it is the correct way of numbering the parent chain. So now I am going to give the numbering to this. Now I am going to write the name of this compound. So what is the order? Primary prefix plus secondary prefix plus root word plus primary suffix plus secondary suffix. What is the primary prefix for this? there is no primary prefix because here it is not a cyclic compound, it is an open chain compound. What is the secondary prefix? Here substituents are present. Yeah, here substituents are present. How many substituents are present? 2 substituents are present because 2 branches are there. So if I am taking this one, if I am taking this substituent, what is the name of this substituent? Meth, eth, prop. That means the substituent name here is propyl because 3 carbon atoms are present. So here the substituent name is propyl and this substituent name is here 1 carbon atom is present. It is methyl, right? It is methyl, it is propyl, right? Here 2 carbon atom, here 2 branches are there. That means 2 substituents are there. So we should have to write the numbering in such a way so that my first substituent should get the least number. It doesn't mean we should have to write this first substituent, the first substituent which get the least number at the first one. We should have to write in an alphabetical order. We should have write in an alphabetical order, right? What I'm saying is that if I'm removing this C here, for example, to make you understand, I'm saying if I'm removing the C here there is 2 carbon atoms. That means it is the ethyl group. It is the ethyl one. What is the substituent name? Ethyl, and this substituent name is methyl. So you can see here, as it is getting the number 3, 3 methyl, and what is the number here? It is a 4 ethyl. I can't write like this. I am saying here 2 substituents are there. I am writing me 2 substituents. One is 3 methyl and second one is 4 ethyl. Just because it is getting the number first numbering, that means it is getting the least number, it doesn't mean we should have to write the methyl first. We should have to follow the alphabetical order while writing the names. While writing the substituents, we should have to consider the alphabetical order. Here the alphabetical order says that ethyl has to come first, then we should have to write the methyl because E comes first in an alphabetical order, right? So we should have to consider the alphabetical order as the number, as a substituent is getting the least number. It doesn't mean that the substituent we should have to write in the first one, right? Okay. So how we should have to write 4 ethyl, 3 methyl. It is what my secondary prefix plus what is the root word here? Meth, eth, prop, but, pent, hex, hept. 7 carbons are present. Then hept is my root word. Hept is my root word and primary suffix is a, as there is no double bond present between the adjacent carbon atoms. Between the adjacent carbon atoms, a single bond is present and here there is no functional group, then there is no secondary prefix. Then what is the compound name? 4 ethyl, 3 methyl, heptane is my compound name. So without the functional group, how to name the complex organic compounds? In this lecture we studied. In the next lecture we will study how to name the complex organic compounds when functional groups are present. And I will give you more examples based on this complex organic compounds without functional groups in the next lecture too. So keep studying, move ahead and focus on your goal and try to achieve it. Right? If you have any doubt or any query, you can comment in the comment section. Your doubts and your queries will be answered very soon. Right? Okay? So take care. All the best. Take none.